Hey there, YouTubers, Arduino users, and fellow roboticists. This is Cameron Owens with the CoroBot Robotic Solutions Group, here with a tutorial on how to use the I2C interface on the Arduino. Now, before we get started, these tutorials are only to provide a very basic introduction on how to use microcontrollers for the main purpose of integrating them into robots. Now, although we are using the Arduino platform, ultimately we will be graduating to the CoroBot Spark, which is a low-cost robotics platform that combines both a Raspberry Pi with the CoroBot Pi Hat. On this Pi Hat is the PSOC, which is a programmable system on a chip developed by Cypress. Now, in order to really harness a lot of the power that is on that PSOC, having some familiarity with both microcontrollers and a little bit of FPGA knowledge is very beneficial. So to get people started with developing on the CoroBot Spark, we're providing some basic tutorials of how to do some very low-level things in Arduino. It serves as a really great opportunity to kind of sink your teeth into developing embedded systems. So let's get started.
Okay. So here's the system that we're going to be using on learning how to use I2C. The first thing that we're using is this Arduino board. For those of you that aren't familiar with electronics, the Arduino Uno is probably one of the most common microcontroller development boards probably in the world. What the people over at Arduino are doing is really great work. So these are pretty cheap. You can get them for about $25. If you want to get the knockoffs or different versions, because all of this design here is open source, you can get them for as cheap as I think $5. You just have to order them from overseas. The next thing that we're going to be using is the GY88 10 degree of freedom IMU board. So this has a 3-axis compass, a 3-axis accelerometer, a 3-axis gyro, and a altimeter. There's a lot of data. Also, there's a barometer on here, so you can measure air pressure, not only altitude. Well, those go hand in hand, but anyway. The other thing is we're just wiring this directly up to the board. So from our breakout board, we just go straight into the Arduino. Now you can use a breadboard. I try to avoid those where possible, just because it can sometimes make things overly confusing. So now with I2C, which is sometimes called TWI, which is two-wire interconnect, or I2C, which stands for integrated communication, you only need 2 wires. Now, I know you're saying there are more than 2 wires here. So let's go through what these wires are. So if we come over here to this board, can I focus? There we go. So we have VN, which on this board we're supplying 5 volts. You can also supply it with 3 volts. This board in particular has a dedicated voltage regulator for doing power control. The next thing that we have on here is brown for ground, and then we have serial clock and serial data. So for I2C, besides powering your devices, all you need is serial clock, which is a signal that tells all of the chips when they're to move to the next line, basically. And then we have serial data, which is the line on which all of this data is transferred. So if we follow this orange line, on the Arduino Uno, now this goes for all Arduino Unos, the official ones, this gets connected to A5. And then serial data connects to A4. So we've got our clock line and then our data line, which is green. So that's pretty much basically it.
So here we are at my computer. I do run typically on Linux. Hopefully we can get this done within the next hour. Now, what's great about Arduino is it'll run on any operating system. I use Windows a lot, I use Mac a lot, I use Linux a lot. They're all great. For me personally, I prefer to develop on Linux for various reasons. But really, an operating system is only a tool. So if you're doing this on Windows or on a Mac, it's all going to be the same. And that's mostly because of the Arduino IDE. Now, I have an alias linked to the latest version of Arduino because I compiled it myself. So depending on, well, helps if I spell it correctly. That's why you use tab complete. So depending on which operating system to launch this guy, which is your Arduino IDE, you can do that various methods. Hopefully you've already played around with your Arduino. So what we're going to do is we're going to come here to my sketchbook and we're going to open up this sketch. Now once I have this video uploaded to YouTube, I'll push all of this to our GitHub account, so if you want to download it you can. A couple of things that I do want to make sure are very clear. So this file I wrote based upon some work that I found online. And so I'd like to give a shout out to CoroBot from FreeIMU, who wrote a lot of really great work. And then also the people at SparkFun, they provide some examples on how to interface with the barometer on this chip, as well as a lot of other examples out there. So although what I wrote is my code, don't be afraid to use other people's code. That's the great thing about open source projects, and we can talk about that later. So the main thing that we're here to learn about is how to use I2C devices. So the first thing that we need to do when we write any Arduino sketch that uses I2C is we first need to include a header file, which is called wire.h. The .h is reference to a header file. This is a library that you use for communicating specifically with I2C devices. So you don't have to worry about any of the timings or anything overly complex. So the next thing that we need to do is we need to find the address spaces for each of the sensors. So as I said, on the breakout board that I'm using, there are 3 independent sensors. So one of the really great things about I2C is that it's a single master multi-slave communication protocol. What that means is that you can have lots and lots and lots of devices all connected to the same communication bus. The way this works is each device will have a unique address. Sometimes, little caveat, sometimes those devices can often share the same address. When that happens, those devices are incompatible and you'd need to put them on a separate communication bus. But for the purposes of this tutorial, we're going to assume that every device has its own unique address. Now, when all of these devices are connected to this network, each device is focused on doing what it's doing, collecting data, displaying things, whatever. Now, the way that the master device communicates to these is it will first call the device by its name or its address. So think about when we were all kids, we were outside playing and things, and we had lots of friends around us, Tommies and Georges and everything, and none of us would really pay attention to what was going on unless we heard our name specifically. That's kind of the same way I2C works. Is along this communication bus, each device is coming along and doing its thing, and it will ignore any communications unless it's specifically directed to that device. So let's go into the Arduino sketch and take a look at how that's done. Okay, 1, 2, 3. Okay, I think we're recording. Okay, so the way that we do this here in the Arduino IDE is we first need to list out the device addresses as variables. This will make it much easier when we're writing our code. It makes it a lot more readable by humans. And so each of these addresses, because each of these sensors is on our breakout board, was found by looking at the data sheets for each device. I don't think I can stress enough the importance of taking a look at the data sheets for the electronic components that you're using. This is really important so that you know how these devices are working amongst a myriad of other things. The next thing that we will do is we'll be listing out all of the variables that we use. So if you take a real deep look at this, I've yet to develop the Kalman filter, which will really provide a lot more accuracy to the sensor. But the rest of these variables are used throughout the code. Now, because we're collecting data, we want to be able to display that data, and so we're using the serial library as well, or the serial functions with a baud rate of 9600. To learn more, you can there are lots of other tutorials on that. But let's really focus on using the I2C. So the first thing that we need to do in our void setup is we need to get the wire protocol, or the I2C communication started. And this is done with wire.begin. Now, scrolling back up here, because we included the header file, it gives us access to these functions. So this wire.begin does a whole bunch of things in the background. The way that you can tell it's a function is by these parentheses. So here in the void setup part, we're starting off the wire communications with a couple of functions specifically to the devices. So after we've gotten started with the wire.begin, the next thing that we need to do is turn on each device. And we do this with doing the wire.begin transmission, writing some data to that device, and then closing the transmission. Think of it as calling one of your friends on a phone. You're trying to get a whole bunch of people together. Actually, even better, think of it as getting people onto a shared game when you're playing on your Xbox. What you do is you call your friends and say, hey, jump on Xbox Live, we're playing Call of Duty, and then you hang up, and then you call up your next friend and say, hey, we're playing Call of Duty, jump on Xbox Live. Basically, that's kind of the same thing that we're doing for each of these devices. We're calling each device with its address, say, wake up and start collecting data, and then we hang up that communication. And then we'll go to the next device and call it and say, wake up, start collecting data, or do whatever you do, and then hang up. In our void setup, we start the communication protocol, and then we're doing each of those phone calls here. So here's an example of doing it to the calling up the compass, saying to turn on, record data, and then hanging up that phone call. We also do that with the MPU, which is the IMU, and then we do something a little different with the barometer. The barometer is a little bit more of a complex sensor to work with and requires a lot more startup. And then we do a delay of 2 seconds just to make sure that everything is turned on. The next thing that we're going to do that we'll focus on for this tutorial is the get IMU data and get compass data. There's a lot of other things that we're doing with our serial prints, which really don't need to be covered in this tutorial. So let's come down here. For simplicity, what we've done is we've put each call for specific data within its own function. So for simplicity's sake, here in our void loop, that's the part of the programming where it tells the microcontroller to go over and over and to loop until it ever turns off, is we've broken down the communication into 3 different functions. I'm still working on the barometer code. I'll send out an update as soon as that's done. But let's really focus on these 2 first functions. We have get IMU data and then get compass data. And so let's jump down to the function where we're getting our IMU data. So that's right here. The first thing that we do, like I said, is we tell the microcontroller to address the device. So basically what we're telling it is get ready to say something to this device. The next thing is we're going to write to a specific register. Now you'll need to take a look at the data sheet for the specific device and for which register that you want to read data from. Typically you write directly to the first register that you want to read from. For most devices that will reset or tell the device to start streaming data from that point. The next thing is to end the transmission, so stop telling the device what to do. And then the next number 4 is you're telling the microcontroller what to expect. So with the wire.requestFrom, the main arguments that you need to focus on is the device address. So we're telling it to listen to specifically the IMU. We're telling it then to expect 14 bytes. And then we have the stop flag of true. So once it receives these 14 bytes, it stops recording. And so here we have wire.read, and we're receiving 2 bytes for each direction. So we have 2 bytes here for the acceleration in the x, another 2 for acceleration in the y, another 2 for acceleration in the z. And this accelerometer actually records temperature too, so we're going to read that data. And then we read the gyro data. And really, that's all that needs to be done to be able to read the data from there. What we're doing later on, though, is we're also serial printing all of those variables to the serial monitor. And then we do the same thing with compass data. So if we scroll down here to get compass data, we do the same exact thing just like we did with the accelerometer. And so we do a wire.begin transmission to the compass address, and then a wire.write. So you have to look at the data sheet to find out which register this is. And then you say stop telling the device what to do, and then get ready to listen. We're listening to the compass address. We're going to be waiting for 6 bytes, and then once that's done, then we end it. So this is kind of something you don't really need to do this. It's just a way to make sure that you're receiving data. So while or if you're receiving less than or equal to 6 bytes, you're going to be getting this data. We could really get rid of this, but it's just I wanted to include it as a different way to show how to program certain things. And then again, just like before, we serial print that data. So let's take a look at what's going on here. So let's upload this. So it's going to go through its compile. It wrote it all to there. And then let's come here to the serial monitor. So it's doing its delay. I waited a couple seconds after it read everything. And now we're reading data. And so if I put my thumb on this, you can see that the temperature is changing. And also I'm going to move it around. You can see that the compass data is changing, as well as the accelerometer data. So let's turn off auto scroll. So here we've got units and all of these. So you can see that some of these are changing. And that's basically it for using I2C. It's a really simple protocol that's really clean and elegant. So yeah, please leave your comments below. And hopefully within the next couple weeks we'll finish up our studio environment that we'll have a better camera setup and everything to do much better tutorials and training. Thanks for watching, and build lots of robots. And that's it with using I2C Communication. It really is that simple. Hopefully you guys enjoyed this tutorial. I apologize for the camera setup. We're still working on our studio environment that we're going to be recording a lot more tutorials in the future. So please stay tuned. The lighting, the camera, all of that's going to change. And hopefully you'll enjoy it. Please leave your comments below on specific things that you'd like to learn, specifically with robotics. We're going to be starting off a lot of the tutorials, very basic types of things, to give a lot of people the general building blocks. Ultimately, we will be moving to the CoroBot Spark, which is a robot platform based off of the PSOC from Cypress, as well as the Raspberry Pi, and some things using ROS, or the Robot Operating System. So stay tuned, please subscribe, and leave your comments below. Thanks!